presentation was actually inspired by something that I can just make a short summary about. I was a grad student some years ago at Louisiana State, Baton Rouge, and there was some forensic investigation that was going on. And recently, they explained in a TV show how actually the original lead that the investigators took was totally wrong. And the key was actually a successful search in a DNA database, which turned the investigation 180 degrees around. So I was like, well, we can explain how actually having this extra knowledge and the possibility to mine into DNA databases can enhance accuracy of any, let's say, hypothetical investigation. So I reached out to Malek, who is a grad student in the Department of Criminal Justice, and I said, well, since you also took classes in computer science, that namely database systems, let's just explain how that was. How that change actually was made possible by having good algorithms to mine databases. Okay, so he will explain a bit more. Thank you.
All right. Good afternoon, everyone. Thank you for being here today for GSU Symposium for 2024. I'm going to be presenting today about actually mixing my minor and my major. I'm going to be mixing computer science and what's technology that we have now with what I'm actually doing right now, which is forensic investigation. So quick bio about me. I just got my bachelor degree last semester, so computer science was my minor. I'm also a current Master of Science graduate student doing criminal justice as well with forensic investigation. Also, I'm assistant in the department, and I always had that thing just to mix disciplines together, just to see what they can do for us. So I have a quick question. If I talk about crime right now, what can be the most common evidence that you can tell me, except fingerprints? Start with DNA, exactly. So actually DNA, and the word is like a big one, I can't really pronounce it, but DNA is like a molecule that have our genes information that they are unique to every person in this world. So basically they are how we develop and how we maintain ourselves and our organism. So DNA basically is, and it's like a pairs of four things. We are like A, C, G, and T. So DNA is random. It could be long, it could be short. It depends. This is how our universe is unique. So, and DNA is biological information. So basically, it's very hard to machines to understand if you put DNA and tell the computers, please read my DNA. So we have to come up with a way in order to transform or encode that information. So if we're gonna talk about computer science, we have also to mention one of the computer science in this world. His name is Fred Brooks. So Fred Brooks was one of the person who got the highest award in computer science, 1991, and it was the Turing Award that made him famous by his article that was, we use computer science as a toolsmith. So how can you use computer science to combine disciplines? So in his article explained also that if you want to use computer science, you have to touch two things, which is the benefit and the satisfaction. So what kind of benefit that we're trying to do, but also what kind of satisfaction. So what's your outputs and what's your rules for that outcome. So this is a quick thing in order how to let the machine understand our DNA. So one of the encoding is one-hot encoding. So basically, this is our DNA we have here. We make it on a table. If you have A in the first one, we're gonna put 1 and 0, 0, 0. If no one doesn't know what's 1 and 0, that's binary numerication for in our computer science and also education system. I'm sure you heard this a lot. So, and we just keep doing that. So if you have a G in second place, we put a G, and we just keep going for everything. So this is one of the most simple one. We have also sequential encoding. So sequential encoding, if you ever seen the helix of DNA in the internet. So they're like two connected together. And if you're gonna look like closer, you're gonna see that there is like interval between the two of them. So that interval could be 0, 2.5, 5, or 7.5. If you go more, which is chimera encoding. So for chimera encoding, we have to pick our key. So if I'm choosing 3, I'm going to take the first 3 letters or character and I'm going to put here. I'm going to go to the second one, just take 3 from there. I'm going to go to the third one and take 3. And by the end, I'm going to have like new information encoded. So I'm sure everyone knows about AI, machine learning, deep learning, and I know there's a lot of professors scared to death of AI because basically you can like train a model to do the whole class for you just by providing information. So AI is like the mother, and we have like machine learning. So basically machine learning, you feed it information and it's gonna learn from that information. So the more that you give it information, it's gonna like process it and like they're gonna be like trained models. So if you go to deep learning is like kind of brains all connected together and they like all communicate with each other. So this is like to simplify those like scary things that we see in society today. So for machine learning, we have a lot of methods. This is one of the most known one. There is more, but it depends on which discipline and what kind of information you have. So the most known one that we see today, especially being here, you may have seen academics and stuff like that, is decision trees. So if you have decision trees, you can see like really what happened. You can like follow up. Clustering for like key means, the one that we saw earlier, and they get like categorized between supervised learning and unsupervised learning. So basically, supervised learning, you can really like kind of know what's really happening while you use that algorithm. One of the most known ones is Smith-Waterman algorithm. So basically, if you have like 2 DNAs, and I need to know, this is basically used for DNA sequencing. So they try to match like kind of 2 DNAs together. This is how kind of they do it. Just one table, like one row and one column, and try to match it together. So I have a quick question, second one. How long does it take to get your DNA back in Alabama if we have a homicide right now? Quick guess.
6 weeks?
Maybe a week. So I see like some answers, but when it comes to homicide, we have to know if it's like we're dealing with state or federal, but for homicide, basically, we're gonna try to put it between state and federal. It's 2 weeks. So you have to wait 2 weeks until to get your DNA results back. That is no less than 2 weeks. When it comes to property crime, things that we can see, he stole my Coca-Cola, for example. If you want to like catch up with the fingerprints or DNA that in the bars, you have to wait at least more than a year. This is for the state of Alabama. And I got the results from consultation with our federal agencies that we deal with. We have Center of Applied Forensics here at JSU. We have also Center for Best Practice and Law Enforcement. So we kind of have that, open dialogue about, what's happening really in this field. So if you go back again to machine learning and how to implement it, so this is kind of what I explained earlier. For classification, it gives you, if you give it a lot of data, it's going to put on categories. If you're going to use a regression, it's going to put it in numerical value. And if you want to go to clustering is like for groups of things. And if you go like dimension reduction, this is like kind of another thing that is going to like pick only one specific thing. So can we really get a face from a DNA? Can we like do a composite or predict a face from DNA? Yes, we can do that. So basically, we take a crossmomp, and just to simplify all of this, as you see, there is a heat map. There is like red spots and blue spots on the faces. So basically, when you link to that area on the DNA or the crossmomp, if it's come back as like blue, that means if this one is a blue, that means like it's going inward. If it's red, that means it's going upward. So we collect all the spots, and we have like kind of final face. So I'm gonna go through some things that where this being used. So actually, I contacted the company that was using this technology. It's in Virginia, and they provided some cases for us. So uh, I'm gonna say some certain stuff. So if you don't feel like learning about random stuff, just let me know. So what you're gonna talk about is called DNA phenotyping. So this is a case that was in Alabama. Actually, they found a guy in Alabama. His head was missing. So basically, there is no head, and there is no way to know who's the person. So they took the DNA and sent it to a person. In this case, went cold. As we know, cold case means there is no solutions. So we sent to this company, and this company used machine learning based on a lot of data. Their models are trained on more than 21,000 like specific data for DNA. And basically, they give you skin color, eye color, hair color, freckles, sex, age, body mass, ancestry, stuff like that. So this case was successful. It was in Marshall County Sheriff Office, like 30 minutes from here. And basically, when police department asked for results, this is what they got. So this is kind of things of results that they might get. And basically, they can kind of use confidence and use like certain things to know how it really goes. That's another one. I'm sure anyone or most of the people know about the Golden State Killer. He was cut by the same like DNA technique. And this has happened after 39 years old. So the case went cold for 39. And you're gonna ask, how can they match this DNA together? So I'm sure many people did some ancestry tests. So basically you submit your DNA to that company, but for privacy reasons, you cannot, like police department cannot go to that company and tell them, hey, I wanna like match your DNA. So it cannot happen like that. So the main company was like GAD match. So basically you can submit your DNA, you volunteer to submit, or then they contact the other companies. And they can get a match most of the time. So it's cool, but what can go wrong in these cases? So we're talking about a machine that we don't really know what's happening inside. It's a machine learning. We have no idea about the decision that it's taken. So basically the opacity is like 100%. We cannot see nothing. And that's why in machine learning and computer science, we call it a black box. You can't really see what's inside. So and this happened in UK. They have a system for offender assessment. So basically they have a person and they're gonna tell him, if I'm gonna have that person, if he's gone like, do I need to take him out in the streets or keep him with me? But how I'm gonna know this? So they've been using UASIS, and UASIS was used like by the higher things in in the government, by the royal family. So basically you cannot ask too many questions about this system. So, but UASIS, when some journalists try to investigate, well, like, what's the assessment? Is there like any reviews about the system? They said like there is only one external review, but there is no results. So you cannot know what's impact that person or that system had on race, gender, or stuff like this. So my presentation messed up, but it's okay. Another problem is
one more minute.
One more minute. So we talk about the overfitting in machine learning, which is like too much data. The program become complex because he learned too much and it started to go crazy. Human intervention as well. That's another problem when you make like wrong judgment. So what solution can we do in our society today? So we need to go from black box model to white box model, basically. So what about we build a forensic investigation white box model for us? So what we can do is build a white box model that has analysis phase where everything is peer reviewed by protocols, how to extract DNA, how to sequence, and after that, we use some algorithms that we can trust. So, and we can annotate as well. So basically, if we have using decision trees, we can use genetic markers to specific outcomes, and we can annotate. And there is some techniques like layer-wise relevance propagation, so we can see what really part we worked on, so we can know what we have. More than that, we can get stakeholder engagement, so we can get feedbacks as well. And we can use also statistical models. So in case you see on your picture over there for those people, there's a confidence level, so we can know how confident of our results. And also we can use XAI, which is explanatory artificial intelligence, so we can know what really happened and how can we explain their decisions. So limitation, of course, as every research, we have privacy. We cannot invade privacy. So bias, fairness, those systems, they can do mistakes all the time. They are machine, they're not human. Even human do mistakes. Population representation, because those machines are trained. So if I take my machine and train it, for example, on certain color of people, what about the other people? They're not trained on that model, and that can make problems. So we need a lot of money, we need a lot of computers. This is kind of ongoing research right now. We need expertise, people who know what they're doing, but also we need to know, it's like kind of trade-off. Do I need a system that can explain stuff or can come back with accuracy? Because if I'm going to have a system that can keep explaining stuff, that's going to take a lot of time. But what about a system that can come back with results as soon as possible? That's all. So if you have any questions.
I think we have time for one quick question. If not, let's thank our speaker.